Hello and welcome back to the Science of Concrete Materials class. This is lecture number 22 of the class, and we are still on the chemical admixtures module. Today we will cover the remaining admixtures. These are the set controlling admixtures and some other miscellaneous admixtures that I will mention briefly. So let's look at the set controlling admixtures first. Before we get into the talk about the admixtures, let us just first review the definition of setting, just for refreshment. The definition of the setting, which is basically the beginning of solidification. So at the initial set, the paste becomes unworkable, so the placement, compaction, and finishing of concrete beyond this point becomes difficult, which is about 4 to 6 hours at 23 degrees Celsius or 70 Fahrenheit. The final set is the time required for the paste to solidify completely, hardening, and strength gain with time. So a retarder basically will increase the setting time, and accelerator will decrease the setting time. Okay, so let's start with the retarding admixtures. Retarders can be used basically whenever it is desirable to offset the effects of maybe the high temperatures that decreases the setting time, or also to avoid complications when unavoidable delays may occur between mixing and placing. So prolonging the plasticity of fresh concrete can be used to advantage basically in placing mass concrete. Successive lifts in a concrete member can be blended together by vibration with the elimination of cold joints that would occur if the first lift were to harden before the next were placed. So retarders can also be used to resist cracking due to form deflection, which can occur when the horizontal slabs are placed in sections. Concrete that has set but has acquired little strength is basically liable to crack when subsequent placements cause the formwork to deflect. If the plastic period is prolonged, the concrete can adjust to form deflections without cracking. So these, some of the advantages of basically retarding the setting of the concrete. Okay, so what is the composition of these set retarding admixtures? For type B, the set retarding admixtures, basically type B in ASTM C494, can be classified according to their chemical composition. The major categories are as follows. First, the lignosulfonic acids and their salts, the hydroxycarboxylic acid, again, I'm having trouble with this, hydroxycarboxylic acid and their salts, sugars and their derivatives, phosphates and organic phosphate salts, and the fifth one is the salt of amphoteric metals such as zinc, lead, and tin. The chemicals falling into categories 1 through 3 also possess water-reducing capabilities and can be classified as water-reducing set retarding admixtures as type D under ASTM C494. So remember that. So how these admixtures work? What is the mode or the mechanism of action? They work in different ways. Let's see first the effect on the C3S hydration. So retarders basically slow down the rate of early hydration of C3S by extending the length of the induction period, stage 2 in the heat of hydration curve, if you refer back to the cement lectures. So the setting time, as measured by the penetration tests or the calorimetry, heat of hydration, the calorimetry, is extended, as also as the strength, the early strength development. The organic retarders are able to strongly adsorb on the nuclei of the calcium hydroxide, and by that they will inhibit their growth into larger crystals. Okay, so further hydration is then prevented until this effect is overcome. The length of stage 2, according as a result of that, depends on the amount of retarder added. But basically, once stage 3 begins, hydration can proceed normally again. Okay, so remember, this is the effect on the C3S hydration by basically extending the induction period. Okay, when inorganic retarders are used, the situation can be more complex, since they also can form coatings around the C3S particles that severely reduce the rate of reaction. So that, again, you have to know what admixture is being used. And also, this information really comes handy in order to avoid any surprises later to your concrete mixes. So also you need to remember that about the extended set control. Overdosing concrete with a retardant admixture, can prevent set entirely. For this purpose, deliberate overdosing has, helped many ready-mix truck drivers out of tight spot. Basically, what a bag of sugar added to the truck can take care of, these emergencies when basically excessive delays may cause the concrete to set up in the truck. So measures are taken in order in events of unanticipated delays to avoid, the hardening of the concrete in the truck, and it becomes too expensive to clean it. Also, carbonated beverages will be even more effective, since they contain phosphoric or citric acids as well as sugars, all of which are retarders. This strategy, can be implemented in a more controlled way, basically using an extended set control admixture, which is a 2-component formulation designed to initiate set at a specified time. What they do, first, a large dose of retardant admixture, which is called the stabilizer, is added, which will delay the setting of concrete for hours or days. At the appropriate time, a set accelerator, which is the activator, is added to overcome the retardation and will initiate set within few hours. Although in practice, an overdose of any retarder should work, combinations of the carboxylic acids and organic phosphates are used basically to avoid complications and ensure predictable performance. Okay, so that is basically what we talked about, the effect on the C3S hydration. Let's see the effects on the C3A hydration, on the mechanism of action. So retarders, again, also tend to retard the hydration of C3A and related aluminate phases. So, but, the interaction between C3A and a retarder is quite complex. And in some cases, the early reactions may be accelerated even though overall hydration is retarded. So an admixture may also be absorbed into the early C3A hydration products while they are being formed. So the C3A admixture interactions basically are responsible for the following observation being reported. So first, the effectiveness of a retarder depends on the C3A content of the cement. More retardant is removed from the solution during the formation of the hydration products of C3A, so that less is available to retard C3A hydration. So you need to know the cement composition. Second, the effectiveness of a retarder is increased if its addition to the fresh concrete is delayed for a few minutes, as you will see here in this figure. I'll talk about it in a minute. Okay, so less retarder is removed from the solution since some hydration products has already formed before the admixture is added. Okay, in the case of the delay. Third, a retarder may cause abnormal setting problems with particular cements. Both early stiffening and abnormal retardation of setting have been observed and reported. So cements from the same mill basically have been found to behave differently with the water reducing admixture. That is dependent on the SO3 content of the cement. So, which appears to be that the aluminate sulfate ratio can be thrown out of balance when the retarders, change the rate of hydration of C3A. Okay, number 4, an admixture again may extend the setting times, but not the time during which the concrete can be handled and placed. So acceleration of early reactions of C3A can affect workability and may promote slump loss. So a retardant admixture may influence the behavior of an expansive cement. You remember? Where the rate of formation of yttringite is changed. So again, using such an admixture with special cements have to be really investigated with care and thoroughly investigated. In addition to what I just mentioned, the content of alkali oxides in a cement may determine the effectiveness of a retarder. So it is not known exactly what causes this, but the presence of alkali sulfate will influence the C3A hydration. Also, it has been deduced that the alkalis may cause the breakdown of the admixture. And again, testing, trial batches, all that is key to making sure no surprises are being met, basically at your job. Okay. Also, again, it has been, suggested that, an admixture cement incompatibility usually can be eliminated by simply changing either the cement or the admixture. So those the trial batches and the tests, again, can go a long way in eliminating any unanticipated problems. Okay, this is the figure I talked about, which shows basically the effect of delay in the addition of the retarder. So basically, this is the set time of the control mix, and here is the final setting time in minutes. Look at what happened here without delay. If we delay just 10 minutes, see how far it goes. So basically, again, this information can only be obtained from actual trial batches and test data made on the same materials you are using for your project. All right. So let's look at the effect on concrete properties of these retarders or retardant admixtures. The influence of a set retardant admixture on air entrainment should be considered, particularly if the admixture also has water reducing properties. Okay, a retarder may also increase the rate of loss of workability in fresh concrete, slump loss, even when abnormal setting behavior does not occur. So again, no one knows exactly what the admixture will do. When this happens, the time during which the concrete can be handled and placed will be decreased, even though the setting time has been extended. So you have to be careful. I told you, I have many stories to tell about surprises from the use of admixtures, and we have gone into very lengthy discussions and very lengthy back and forth in order to explain what happens. Also, as mentioned, earlier, retardation increases when the addition of a retarder to concrete is delayed a few minutes after the first addition of water. So retardation is increased rapidly up to about 10 minutes, depending on the admixture type and dose, and then slowly decreases as shown in this figure here, okay? So consequently, an additional dose of water-reducing admixture can be used during retempering of a fresh concrete, basically without prolonging setting times, unduly, and without compromising the performance of the hardened concrete, which adding water will do, okay? Whenever a retardant admixture is used, some reduction in the 1 day strength of concrete should be anticipated, unless of course there is a reduction in water cement ratio also at the same time. But the strength should basically approach that of unretarded concrete within 8 days, unless an overdose has been used, as you can see here. So retardant admixtures, have been reported also to increase ultimate compressive strength and to a lesser extent the flexural strength. Although, set controlling admixtures have been reported also to increase drying shrinkage and creep, the effects are not large and often depend on changes in mix design, time of hydration, time of drying, or loading. But, laboratory work indicates that admixtures increase the rate of drying shrinkage and creep, but not the ultimate values. Okay, here is the this figure I talked about. As you can see, the effect of the set modifying admixtures on strength development of concrete. Look at this curve. The solid line is the control, no admixture is added. This line here basically is the accelerated, and this is the over retarded. Look at the early strength. Of course, this accelerated has higher strength, but ultimately lower strength. On the other hand, the over retarded mix, look at it. The early strength gain is much lower, but the ultimate strength is higher. Okay, so let's now look at the accelerators. When considering a set accelerating admixture, it is important to distinguish between admixtures that accelerate the normal process of setting and strength development, and those, the others that provide very rapid setting characteristics not normally associated with Portland, with ordinary Portland cements. Quick setting admixtures basically provide setting times of only a few minutes and are used in shotcreting applications or for plugging leaks while under hydrostatic pressure, and for emergency repairs, in general, where rapid development of rigidity is required. So that's the difference between the normal set accelerator or the quick setting. The irregular accelerators basically are used to speed up construction, basically by permitting earlier finishing of flat work and earlier attainment of sufficient strength to allow removal of formwork and to carry construction loads. All right. Accelerators are beneficial basically during winter concreting by partially overcoming the slower rate of hydration caused by low temperatures and shortening the period for which protection against damage by freezing is required. When you place concrete in freezing environments, many things you have to do, one of which is to provide protection in order to make sure freezing does not occur. But we could use the accelerators in order to overcome this issue and basically get rid of this inconvenience. However, as will be discussed, accelerators can negatively impact the other properties of concrete, and so they should be used with caution. And again, really, this is almost with every admixture. All right. So what is the composition of these accelerators or accelerator admixtures? We can divide accelerating admixtures into three groups. Basically, first, soluble inorganic salts, soluble organic compounds, and the third one, some miscellaneous solid materials. Many soluble inorganic salts will accelerate the setting and hardening of concrete to some degree, basically with calcium salts generally being the most effective. Calcium chloride is the most popular choice because, it gives more acceleration at a particular rate of addition than other accelerators and also reasonably inexpensive. But, in reinforced concrete, it has been replaced by calcium nitrate, which basically does not promote corrosion because the addition of chlorides to your concrete mix is not something you want to do. Okay. Also, we have other admixtures. Soluble carbonates, aluminates, fluorides, and ferric salts have quick setting properties. Also, sodium carbonate and sodium aluminate are the most common ingredients for shotcrete admixtures formulation used, to promote quick settings. A variety of organic compounds have accelerating properties, although many more act as retarders. So again, care should be exercised when selecting these admixtures. For example, these example of these organic compounds like ethanolamine, calcium formate, and calcium acetate. These account for most commercial uses. The triethanolamine is commonly used in formulations of water-reducing admixtures, basically to offset their retarding action. Although this also is listed as an accelerator. So recent research shows that its reaction with Portland cement is rather complex. So it can cause a retardation or a flash setting depending on the amount used. And again, surprises from these admixtures. First, of course, it has to be, you have to consult the material manufacturer, the ready mix supplier, and also trial batches and testing. This is the key. Okay. So again, many more products still exist. Maybe solid materials, are often also used for acceleration, like calcium fluoroaluminate or calcium sulfoaluminate. Can be used as admixtures to obtain rapid hardening characteristics. The addition of calcium aluminate cements cause Portland cement to set rapidly. Remember, we talked about the calcium aluminate cements. And concrete, can be maybe seeded by adding fully hydrated cement that has been finely ground into during mixing, basically to cause more rapid hydration. The finely divided carbonates, like calcium or magnesium, silicate minerals are also reported to decrease setting time. So again, many products exist out there, and again, consult the people of experience with these admixtures. Make sure whatever is proposed fits the requirements of your job, and above all, make sure you comply with whatever specifications you are required to comply with. Testing and trial batches, that's all I can say. Okay, how these accelerators work. The conventional accelerators, basically have exactly the opposite action that retarders have. They increase the rate of hydration of C3S and the rate of strength development, as basically as shown in this figure. The accelerator, they increase the rate of hydration and the early strength development. Okay, so generally the induction period is shortened and the rate of hydration during stage 3 and 4 are increased. So this is the case with calcium salts. The addition of the admixture basically increases the rate at which the calcium hydroxide crystal nucleate and grow. Organic accelerators, on the other hand, are believed to act, by increasing the rate of hydration of C3S. All right. The quick setting admixtures, cause flash setting of C3A by promoting very rapid hydration on contact with water. So admixtures that affect C3A hydration can also be expected to affect the expansion characteristics of expansive cement. Remember this, when expansive cement is being used, any of these accelerating or retardant admixtures should be used with care and without full testing and basically understanding its effects. I will not use it. So let's look at how these set controlling admixtures really affect the concrete properties. As we said, every admixture should be every admixture, whatever it is, air entraining, water reducing, set retarding, set accelerating, all these have effects on concrete and it should be investigated. But, from what we know, accelerators do not, as a rule, have adverse effect on air entrainment. Although trial batches should be used to check this. Again, we go back to trial batches. It must be remembered that the use of an accelerator will cut down the time during which concrete can be handled and placed, so that, reliable scheduling of construction operations is necessary. And again, you have to remember this. If your concrete is being dosed with accelerators, make sure you know when to order the concrete and to place it quickly before it's too late. Also, accelerating admixtures may require some additional water if early stiffening occurs. But this, this is just general statement. But nowadays, they can be formulated with a water reducing admixture. So we will not add water. Regular accelerators, can be expected to increase the one-day strengths. The increase basically depending on the type and dosage of the admixture and basically on the temperature, because it affects hydration. So an optimum dose of calcium chloride, assume it's being used about 2% by weight of cement, will approximately double the one-day compressive strength of concrete, again dependent on the current temperature. However, though, the increases basically diminish with time, and later strengths, at 28 days or more, are likely to be lower than the strength of concretes without an accelerating admixture. If you refer back to this figure right here. You remember what I told you? This is the accelerated. Look at here the 28 days and ultimate strength being lower than that, the retarded concrete. Okay. Okay. So basically the extreme case is that, you know, some quick-setting admixtures which may have lower strength at 1 day, even though some strength is obtained very rapidly. So again, testing has to be done in order to investigate and understand the effects. Also, accelerating admixtures are said to increase the drying shrinkage and creep. But, you know, as I mentioned in the previous discussions, you know, as with retarders, it is the rate of deformation rather than the ultimate value that is affected. And again, I will not pass judgment completely, still out there, you know, it has to be investigated. But, you know, the early shrinkage leads to high tensile stresses in restrained concrete, resulting in an increased cracking. So again, many factors, you have many variables that have to be investigated. Also, tests have shown that the use of calcium chloride in concrete reduces its resistance to sulfate attack and also aggravates the alkali aggregate reaction. If these are potential problems in your job, calcium chloride, aside from the corrosion issue, should probably be looked at carefully. The quick-setting admixtures, you know, can be expected to reduce the durability of the concrete or mortar if they have an adverse effect on strength. Okay, so ultimate long-term strength should be verified. Also, calcium chloride can discolor concrete and should therefore never be used in architectural concrete. As I said, really, many variables, and every aspect of your concrete should be investigated when it comes to these admixtures. You never know what they will do. I'm sorry to say this, sounds like a general layman statement, but this is the case. Okay, with regard to the corrosion of reinforcement, as I mentioned, a major disadvantage of the use of calcium chloride is its tendency basically to increase the rate of corrosion of metals embedded in the concrete. And as I said, you know, in the distant past, addition of calcium chlorides up to 2% by weight of cement were considered safe to use in ordinary reinforced concrete, provided that an adequate cover of dense concrete was provided. But, you know, the ACI building code places limits on chloride content of the concrete that basically preclude its use for both pre-stressed and conventionally reinforced concrete. You know, there are other chloride-free accelerators, you know, that exist, should be used in such cases. So with the chloride, as I mentioned here, the code does not say, the ACI building code does not say do not use calcium chloride. But in the code, there are limits of the total amount of chlorides that can be present in a mix, which are different, you know, for conventional concrete and pre-stressed concrete, being much lower for a pre-stressed concrete. You know, having these limits basically will render the calcium chloride not allowed, you know, by that virtue. Okay, so that although it's inexpensive, it is effective, but not to be used. Okay, so these are basically the effect on concrete properties. And by this, you know, we have finished the set, control, and admixture discussion. Just as I mentioned, to be thorough and for the sake of completeness, there are other admixtures that, you know, exist out there for other purposes. I will mention them here briefly. And if any further discussion is required, or any of the audience may be required a further discussion and on any of these admixtures, they could contact me and we will discuss it. So the first category is the viscosity modifiers. These are high molecular weight water-soluble polymers which are used to raise the viscosity of water. They increase the cohesiveness of fresh concrete and reduce its tendency to segregate and bleed. Okay, we can do this with other admixtures, but nonetheless, this admixture exists. We have the corrosion inhibitors. We will talk about this during the durability lectures. This can basically improve passivation of steel and or limit the migration of chlorine and moisture through the concrete, such as the calcium nitrite, amines, fatty acid esters. And again, there are other measures to be taken to combat corrosions, but nonetheless, this corrosion inhibitor admixture exists. We have shrinkage reducers or shrinkage reducing admixtures. These reduce the surface tension of water in the paste, basically decreasing the stress on the pore walls and by that reducing shrinkage strain. Never use them. And again, if you remember when I talked during the talk about the hydration and the development of the microstructure, we said we need to understand what happens and how the concrete properties are impacted by the microstructure and what can we do to improve the microstructure. I mean, using these admixtures, although they are used not extensively, but whatever these admixtures add, the value they add, in my opinion, of course, can be done with many other things that we can do to improve the concrete microstructure, basically to reduce shrinkage, combat corrosion, and we have other ways basically to reduce segregation and increase the cohesiveness. So everything here can be done with certain practices and more understanding. We have also alkali aggregate reaction inhibiting admixtures. Obviously, it's used to reduce expansion caused by ongoing alkali silica reaction. And again, other ways to reduce it. We have an anti-freeze admixtures. Basically, these, they could be good. Basically, they allow placement at cold temperatures, up to 5 degrees Celsius. Okay, so again, think about them. If you need more details about these admixtures, we could discuss. Okay, by this, this is basically the end of lecture number 22. And by this, we have finished the chemical admixture module of the class. And next time, we are going to start on a new module. And again, first of all, thank you for watching. And I hope you guys, you gentlemen, can, or you folks, I'm sure maybe more people are watching, I hope, will give me any feedback you feel is necessary to improve. I will welcome all your feedback in any direction it goes. I don't mind, and I will basically answer any questions or engage in any discussions necessary to basically clarify anything that has been presented. Again, thank you, and I will see you next lecture.